Good afternoon, everyone. I am Joel Kenneth M. Ngoha. Today, I will be discussing the solidification and stabilization treatment. Before we begin with the lecture proper, let us first define terms that we will be encountering later on as we progress. Additive. These are substances added to improve the immobilization of specific contaminants. Encapsulation, the process of continuous coating of inert materials into the waste. Leachability, the removal of soluble or other constituents by the aid of percolating liquid. Remediation, the removal of contaminants from soil, surface water, groundwater, or sediments. Vitrification, the process of converting radioactive liquid and chemical waste into a solid, stable glass. To begin with, let us define solidification and stabilization treatment. Solidification and stabilization treatment is a process that involves the mixing of waste with a binder to reduce the contaminant's leachability by both physical and chemical means. This waste treatment converts the hazardous waste into an environmentally acceptable waste form for land disposal, reuse, or recovery. This treatment has been frequently used for the treatment and immobilization of soils, sludges, and other types of waste containing contaminants. Actually, there is no standard method in its application, but the selection of the appropriate binders, the solidifying and stabilizing agents, are very crucial to successfully treat contaminated wastes. Note that the solidification and stabilization treatment does not destroy the waste and the contaminants it contains, but rather it tends to prevent its release into the environment. The solidification and stabilization treatment can be carried out through these two applications presented below. We have the ex situ application and the in situ application. For ex situ application, this involves the removal of waste from its location and transferring it to a treatment plant for processing. So the ex situ treatment happens off-site, where contaminated waste is excavated and it is transported to a special facility where appropriate remediation for waste is performed. The in situ application is the process where the waste remains at its location and the solidifying and stabilizing agents are injected with specialized augers and equipment. So for this application, it mostly happens on-site where solidifying and stabilizing agents are injected into the contaminated area for remediation. This process can be done through backhoe-based methods, drilling or trenching methods, and shallow area method. So you might be wondering which application is better. So in terms of cost effectiveness, the in situ application is better compared with the ex situ application. In situ is way cheaper than the latter. However, when it comes to the operations and methods, the ex situ is more thorough, effective, and efficient compared with the in situ application because wastes that are treated through ex situ application underwent a uniform and controlled treatment. The treatment is mostly done off-site and are transported into a facility where everything is regulated. We have here the solidification process. It is a technique that physically encapsulates a waste, forming a solid material that does not necessarily involve chemical interaction between the contaminants and the solidifying additive. So for this process, waste is normally treated to entrap the waste materials into a solid or crystalline form with a low surface to volume ratio. We have here an example of soil remediation through solidification process. So this process involves the injection and blending of solidification agents. So for this specific treatment, a cement additive is utilized that would help turn the soil and contaminants into a solid state to isolate the contaminated parts and to prevent the spread of contaminants to other areas. The stabilization process is a technique that chemically reduces the hazard potential of waste by converting the contaminant into a less soluble, mobile, or toxic forms. So this process involves the use of stabilizing agents that facilitates a chemical reaction to increase the binding power or force between the soil and the contaminant to help prevent the spread of it. And it also helps reduce the leachability of the stabilized waste after treatment. This treatment will help convert the waste into a stable, insoluble form. Presented on this slide are the types of solidification and stabilization method and its application. For sludges and contaminated soil, the appropriate method is a solidification with a cement additive. For some inorganic wastes and waste from desulfurization treatment of waste gases, we have solidification process with lime additive. For radioactive waste, we have solidification with thermoplastic materials. For sludges, liquids, and some particular materials, we have encapsulation. For radioactive waste that are extremely hazardous, we have the vitrification process. So these types of methods and processes will be discussed further by my other groupmates. How are solidified and stabilized treated waste disposed? Waste activities are classified as either disposal or recovery operations. Wastes that are not recovered are deemed to be part of a disposal operation, and these wastes are disposed into landfills, and it is classified into two. We have the inert landfills and the hazardous landfills. For inert landfill, it is a disposal facility that only accepts wastes that are not likely to cause production of leachate. These include wastes that are neither biologically nor chemically reactive and will not decompose. So such wastes are concrete, sand, gravel, metal scraps, and asphalts. We have the hazardous landfills. It is a disposal and a treatment facility where hazardous wastes are placed in or on land stored inside a secure drums. Hazardous waste facilities are regulated more strictly than the regular landfills since they handle potentially dangerous byproducts. One of the most important ways they keep the surrounding environment safe from the material disposed is to keep a distance of separation between the bottom part of the landfill itself and the bedrock or groundwater situated below. This is done to avoid contamination of groundwater. So what happens to the wastes that are not disposed? In a recovery operation, treated wastes are reclaimed and restored, where these treated materials replace non-waste materials which would have to be used for another purpose. Any kind of waste, whether it is inert waste, non-hazardous waste, or hazardous waste, is capable of being used in a recovery operation as long as it is suitable for the purpose it is intended to. But in order to do so, the operator or the handler of the recovered waste must submit a waste recovery plan to the environmental agency for approval on utilizing the treated waste material again. Let's have a short recap on everything we've discussed so far. Solidification aims to minimize the spread of pollution by converting the contaminated materials into a solid impermeable mass. This is often achieved by adding a binder or a solidifying agent. Stabilization is a process where chemical reagents are added that helps convert the contaminant into a less soluble form through chemical reaction or pH adjustment. Solidification and stabilization treatment can be carried out through ex situ and in situ application. Ex situ application is mostly done off-site, while in situ application is mostly done on-site. Treated wastes can either undergo a disposal operation or recovery operation. And that concludes my report. Thank you for listening.